It's the same kinematics, and in kinematics, you know that we study the motion of the object without knowing the cause of motion, right? Something is moving from one point to another point, right, with some speed, with some acceleration, right? So we are concerned with the speed, we are concerned with the acceleration, but we are not concerned with why the body is moving, what is the cause of motion, right? We never talk about the forces in kinematics, right? So already we studied the 1D motion. 1D motion means when something moves in a straight line, right? Straight line along the x-axis. So that is a 1D motion. Or you can say if something moves vertically, right, along the y-axis, that is also 1D motion, right? So in 1D motion, the object moves with certain speed, with certain acceleration, right? But we never study why it is moving along the x-axis, why it is moving along the y-axis. We are not concerned with the cause of motion, right? So 1D motion, and in the 1D motion already we studied the displacement time graph, we studied the velocity time graph, right? So now finally today's topic is the projectile motion, which is a 2D motion, right? So projectile means when we throw something, so that moves in a parabolic path, right? When I throw something that moves in a parabolic path, right? And that parabolic path, basically that is a projectile motion, right? You throw anything, small or big, that moves in a parabolic path. So the motion is a 2D motion. How that is a 2D motion, right? Suppose, for example, I throw this ball, right, like this, vertically, making some angle with the x-axis. This is my x-axis, right? So it makes, I throw something making an angle theta with the x-axis, right? And the velocity of thrown is v meter per second. So I throw something with a speed or with a velocity v meter per second, right? So what will happen now? When I throw something with a speed v meter per second, what will happen, right? So first it will go like, it will make a trajectory like this. It will go to the highest position, right? Stop here momentarily for few nanoseconds or for some time. Then finally it will come down and it will hit the ground. Okay, finally it will hit the ground here. So this path is known as the parabolic path. Okay, so this is a parabolic path because this is a parabola. Parabolic path. In this parabolic path, the motion is 2D. How the motion is 2D, right? You see, it is moving along the x-axis also and it is going up also. So it has a y component also, right? It has a y component also. So I throw something, some object at some angle theta with the x-axis. X-axis is the horizontal axis, y-axis is the vertical axis. So I throw some object making an angle theta with the x-axis, right? Now the object is moving along the x-axis because from starting point to the end point it travels along the x-axis. But it travels certain height also, it travels along the y-axis also. So because the same object which I throw at certain angle, that is covering two distances, x-axis also y-axis, right? So it means this type of motion, that is 2D motion, right? Where the object travel along the x-axis as well as along the y-axis. Clear? So when the object travel along the x-axis as well as y-axis, so it means the velocity v, that will also be resolved into two components, right? Now I will resolve this velocity into two components. One velocity along the x-axis, that is known as vx. One velocity along the y-axis, that is known as vy, right? Because we have angle theta, so now I can write vx as v cos theta, right? And vy as v sin theta. Okay? So because this is a 2D motion, in the 2D motion I will resolve the projected velocity v. This is a projected velocity, means I projected the ball, I projected the object at certain angle theta. So the velocity along the x-axis, that can be written as vx equal to v cos theta. velocity along the y-axis, that can be written as v sine theta, where theta is the angle between the this velocity and the x-axis, right? So now we have two velocities. So these are known as resolving the velocity into component, right? So I resolve this velocity into component, right? So finally, so component of velocity v, right? So component of velocity, it has two components. One is the v sine theta and other is the v cos theta. So these are the component of velocity, right? So in 2D motion, in projectile motion, which is a 2D motion, any object moves with two velocities, right? One along the horizontal direction, other along the vertical direction, right? So this is known as the projectile motion. So let us take one example. But before the example, let me write the necessary equations which I will use in the projectile motion. So already in 1D motion we discussed the equations of motion, right? So very fastly let me write the equations of motion, right? So equations of motion. When anything that moves with certain speed, that moves with certain acceleration, that takes some time, and that travels some distance, right? So means we are concerned with the speed, we are concerned with the speed of motion, right? We are concerned with the acceleration of the motion, and how much time is taken from starting point to the destination point, right? And the displacement, right? You can say the displacement or you can say the distance, right? You can write the speed or velocity, this is acceleration, time, displacement or distance, right? So these are the few things. So how these can be connected? They can be connected by a few equations which are known as equations of motion. So Sophia, first equation of motion. V is equal to u plus a into t. This is first equation of motion. What is V? V means if anything starts from point P, reaches to point Q, right? When the object was at P, initial speed that can be written as u. Initial speed is u, right? And final speed that can be written as v, right? If the object at P is in rest, then we say initial speed is 0. Okay? If something starts from P but initially at P it is in rest, then we say its initial speed is 0. At Q, when it crosses Q with speed v, right? And time taken from P to Q, the time taken from P to Q is t, right? Distance traveled between P to Q, right? P to Q, the distance traveled. Distance is, you can write distance or you can write displacement. So that is written as S, meter. Okay, time is in second and distance between P and Q. Okay, so the first equation, this is the final speed at Q, u is the initial speed, and a is the acceleration. Acceleration means when object starts from P, crosses Q, there is change in speed, which is known as acceleration. How much time it took from P to Q, that is t, right? Likewise, I can write the second equation of motion. So that is S is equal to u t plus half a t square. What is this S? S is the distance, yes, distance or displacement between P and Q. U is the initial speed again, t is the time, a is the acceleration between P and Q, again t is the time. Okay, third equation of motion, v square is equal to u square plus 2as. Again, final speed at Q, initial speed at P, acceleration between P and Q, and distance between P and Q. We can use one more equation, right? And that is the average speed. So average speed, this is average speed. Average speed is equal to final speed plus initial speed divided by 2. So these formulas or these equations, they are helpful in studying the 2D motion, especially the projectile motion. Okay, so now we will start with the 2D motion, which is the projectile motion. Okay, done? Done? Mario, any doubt up to here? Any doubt? So let me write the question which we are going to study today. First I give you a question, right? So we have suppose we have a tennis player, the tennis player that strike a tennis ball, right? The tennis player that strikes a tennis ball, so that the condition is that, the situation is like this. The tennis player, right? So the tennis player, this is a tennis ball, okay? So the tennis player strikes the tennis ball and the ball goes like this, right? And the speed of the ball is 40 meter per second, right? 40 meter per second. And when it hits the ball, it makes an angle. It makes an angle 45 degree with x-axis. When the tennis player strike the ball, when the tennis player